How are y'all today? All right. So hopefully Olivia will join in just a minute, but we'll go ahead and I'll share my screen and we'll get started. Everybody looking forward to having a week off next week? Let's see. Okay, so when we left off the other day, we had talked about our congruent polygons, and we looked at recognizing our marks that we use. That we talked about with congruent polygons. We needed to make sure that we are looking at the sides as well as the angles. And so when I talk about congruence, that means that two figures, two polygons, will have sides that are congruent to each other, or sides that equal each other, and angles that are congruent, or sides or angles that have the same measures to make them congruent. Okay. So when I talk about congruence, I'm talking about same size, same shape. Okay. Same angle measurements, same length measurements, same everything. Okay. I think the mailman's dropping something on my porch, and I bet my dog's sorry. I could see him walking up, and I knew she was gonna go nuts when she saw him. Okay, so same size, same shape, same angle measures, all that good stuff. Okay. And then actually, I told y'all that I kind of jumped over and did the same thing. We talked about lesson 89, where we said we have different types of triangle congruence. And we said that the first one was side, side, side congruence. And so that was when I have three sides of one triangle are congruent to three sides of another triangle. So that's side, side, side. Side angle side is where I have a side and an included angle. Okay, so side angle side means I've got two sides and then there's an angle between them that are the same. And then I have angle side angle, and that's going to be where if I have a triangle and I have an angle and then a side and an angle. Okay, so they follow, they go right after one after the other. And then angle angle side would be like if I have an angle here, and then a side. Okay, so they just go right one after the other. So those are four different ways that I can show that two triangles are congruent. If three of the sides are congruent, if two sides and an included angle for side angle side, if two angles and an included angle for angle side angle, or if two angles and a side when they're in order angle angle side. Okay, so those are ways that I can show that triangles are congruent. So we looked at activities 2 and talked about that. And like I said, these are just things that we are kind of just touching on right now, getting us familiar with certain terms and things like that. Let's go ahead and take a look at activities 4 on page 196. Activities 4, page 196. All right, so it says draw a picture and solve. So let's think through these. So it says, what is the length of each side of a square if the area is 121 square feet? All right, so there's a couple of things that I want to look at this. I want to see what information they've given me. What am I working on? So I know I'm dealing with a square, so I have to think about what things do I know about squares, okay? I'm talking about lengths of sides. So what do I know about the lengths of sides of squares? They're all what? They're all the same length, right? So I know that if this is X, then this is X, and this is X, and this is X, right? So when I think about my formula for area, I know that when I find area, I know that the area formula for a square, we can either use side squared, or we can just say side times side, which is the same as side squared, okay? So in this situation, I know, or I don't know my side numbers, but I do know my area number. So what I'm going to do is I'm going to plug in 121 for the area. So I know that 121 square feet is equal to side squared. So now, one of the things that we haven't really talked too much about, we dealt with it a little bit earlier in the year. It'll be something that we'll deal with more in algebra next year. But if I am dealing with, you know how we talked about how our opposite operations can undo things, like I can use addition to undo subtraction, or subtraction to undo addition. I can use multiplication to undo division, or division to undo multiplication. When I'm dealing with exponents, and I have something to the second power, if I have a number squared, then I know that I can take the square root of it. So my opposites of exponents to the second power, the opposite of that is going to be square roots. So think about, if I have 4 squared, I can take the square root of that, and that will just be 4, okay? So in this situation, I need to undo this. So I'm going to take the square root of 121 and the square root of my side. So I'm going to have side is equal to, and let's think about our perfect squares. What times itself equals 121? What times itself equals 121? That's going to be 11. 11 times 11 is 121. Okay, so I know that each side is 11 feet. So what I did is I looked at, Olivia, we're on page 196, activities 4. So by looking at the information they give me in my sentence, I know that I'm trying to find the length of a side. I know when I have a square that all of my sides are equal. In my area formula, I can either use side times side or side squared, and it says that it's equal to 121. Anytime I have something squared and I need to find out, so if I have a variable squared, if I have x squared, if I have t squared, if I have s squared, whatever it is, to find the value of just a single t or x or s, I have to take the square root of it. But if I take the square root of one side, I have to take the square root of the other. All right, so let's take a look at the next one. What is the width of a rectangle if the perimeter is 28 centimeters and the length is 9 centimeters? So what I want to do is, I know that a rectangle, I know for perimeter, I have 2 times the length plus 2 times the width. Or I could use perimeter equals length plus width plus width. Either way. Okay, so now they've told me that the perimeter is 28. So I'm going to plug in 28 for my perimeter. They've told me that my length is 9. So they've said I've got 2 times 9 right here. I'm trying to find the width. So I'm going to have plus 2w. Over here, I could say P is equal to 9 plus 9 plus w plus w. I'm going to end up eventually getting to the same exact thing. So here I've got P is equal to 18 plus W is 2W. Over here, I'm going to end up with 28 equals 18 plus 2W. Whoops, and over here I meant to put my 18 as I meant to put 28 as my perimeter. So either way, whichever formula I start out with, now I'm back to the exact same thing. Okay, so you can use either formula, but now I've got to solve for W. So that means I'm going to need to subtract 18 from each side, and 28 minus 18 is going to be 10 equals 2W. So the first thing I had to do was I had to undo my addition by using subtraction, or I had to move a positive number from the right to the left. So to move a positive number, I have to subtract it. Now I have to divide to get 2 and W apart. 2 and W are being multiplied, so I've got to divide both sides by 2, and W equals 5. So now I know that the width of my rectangle is going to be 5 centimeters. Okay, so I use the same formulas, I identify what I know, and I solve for what I need to know. Okay, and also on this it did say to draw a picture, so again, if it helps you, you can draw the picture and say, hey, this is 9, that is 9, and that was X, and that was X, so we had to solve for that. Okay, let's go ahead and look at the next one. I'm going to erase a little bit of this so I can. All right, what is the circumference and radius of a circle if the area is 144 pi millimeters squared? So let's think about our formula. So again, we're having to find circumference. That is a terrible circle. But so I think about, I've got to find, and so there's my radius. So think about my formula for area equals pi r squared. Okay, so I'm trying to figure out what is the radius if I plug in 144 pi is equal to pi r squared. So I know that my pi is staying the same on either side. So basically I have 144 is equal to r squared. So again, when I have a variable raised to the second power, the way to solve for r, to solve for a single one, is I've got to take the square root of both sides. So I have to ask myself what times itself is equal to 144. And so, good, 12. So I know that 12 is equal to 144. 12 times 12 is 144. So that means I'm going to have 12 millimeters is going to be my radius. Okay, so using my formulas can be a super helpful tool if I just go ahead and plug in my formula. I plug in the information that I know so I can solve for what I don't know. We did the same thing with our other problems. Oh, I skipped over one, didn't I? I jumped over that one. So let's go back up one. What is the height of a triangle? Okay, so what I'm going to do is I know I'm drawing a triangle. If the base is 3 inches and the area is 15 square inches. So my base is 3 inches and I'm trying to find my height. Okay, so remember, the area of a triangle is 1/2 base times height. Okay, so I know that the area is 15 inches squared. So that equals 1/2. They told me my base is 3. So I'm trying to solve for my height. So I'm going to go ahead and work through this. And so it says 15 inches squared is equal to. All right, so what I'm going to do first is I'm going to say, what is half of 3? All right, I'm going to go ahead and change that to a decimal, and that's going to be 1 1/2. 1 1/2 is half of 3, so I have 1 1/2 times h. So that means I can divide by 1 1/2 on each side. Okay, so 15 divided by 1 1/2. What can I multiply 1 1/2 by to get to 15? One of two things. I can use a calculator and say 15 divided by 1.5. Or you might already see that, hey, if I have 1.5 and I move my decimal one place to the right, then that equals 15, right? So what does that mean? I multiply 1.5 by to get to 115, I'm multiplying by a power of 10. So when I divide by 1.5, then I can see that the height is equal to 10 inches. Now, once I have found my number, I can always try to plug it in to check and say, does that make it true? So I just found out that h was 10. So if I were to plug this in and have 15 inches squared is equal to 1/2 times 3 times 10. Well, 3 times 10 is 30. Half of 30 is 15. So I see that I have found the right answer.
I did that another way. Like I did 15 like times 2 because that's 1/2. So
Absolutely.
30 and then divide
Yes.
by 3.
Yeah, so remember we've talked about that if I have a fraction and I want to clear my fraction, I multiply by the denominator. So if I multiply this side by 2, that means I multiply this side by 2. So then I end up with 30 is equal to 3 times h, divided by 3, and h is 10. Absolutely, good job. But the main thing is that sometimes it helps to draw us a little picture to identify what we know, look for what we don't know, use those formulas, use what we've already learned, plug in the pieces of information that they give you, and then solve for what you don't know. Okay, good job. All right, so now what I want to do is we are going to back up to lesson 88, which is on page 193. And talk about symmetry. Now, a lot of times when you're little, you deal with symmetry, maybe with art projects, how you talk about how sometimes you might have a piece of paper. The one I remember very vividly, as I remember, and when I was in 5th grade, I remember we did a project where we had our piece of paper and we folded it in half. And so then we drew something on half of the other side. And I think I did a butterfly. For some reason, that just rings a bell. I also remember doing like a self-portrait. I can remember that, but I don't remember what grade that was in. But basically what we would do is we would fold our paper in half. And whatever we drew on one side, we had to draw identically on the other side. And for some reason, I want to say at some point, I also remember doing it where you did your crayon really hard on half of it. And then when we folded it in half and we would rub real hard and it would transfer a symmetrical image on the other side. And so those are kind of things that I remember learning about symmetry. Does anybody have any other stories on anything that they learned, how something that sticks out in their mind with symmetry? Okay, so one of the other things that we can think about is like a mirror image, like when we look in the mirror and what we have reflected back is, we've got that. So basically, when a polygon, when a shape has symmetry, it's usually there's going to be a line that makes half of the polygon congruent to the other half. So when we look right here, like if we look at our parallelogram, typically we think about, can I cut it in half? Okay, well, when I cut this in half, if I were to fold it on top of each other, it's not going to match up perfectly. Same thing if I were to cut it this way. When I cut it from top to bottom, and if I were to fold that down over the top, it's not going to match up perfectly. So my lines of symmetry are not vertical and horizontal here, but a parallelogram has diagonal symmetry. So I can go from vertex to vertex. I can go from corner to corner. And when I have a diagonal, then I can see I've got that symmetry there. So I can see when I'm looking at that. Now, also, my symmetry going this way is going to slant. So
that last one isn't congruent. Like that one doesn't form congruent halves.
So when I think about being able to fold it, it's not, but if I were, so one of the things that we're talking about parallelograms and talking about symmetry is sometimes it could be, I have to do some type of either a rotation or a slide. Now, if I were to cut these two in half, like if I were to cut along that and I actually made them separate pieces, then I could lay it on top of it. Okay, so that's kind of shifting our thinking about, usually we think about, hey, if I draw lines like this, then it's got to work out perfectly. But when we talk about symmetry with a polygon, when I'm looking at it as if I could cut it apart, just like my diagonal symmetry here, if I were to fold that, it would not work. But if I were to cut it apart, then I could see where where CB, if it was laid where DA was, and then this point here came down here, then I can see where it would have symmetry. Okay, so we're kind of looking at it a little bit differently now. But one of the things to notice is that a parallelogram, notice it has 4 corners. It has 4 vertices, and it has 4 lines of symmetry. Okay, so if I were to do it all on the same figure, then I could look at it, it would go through here, and then it would go through here, and then through here. So I can actually see where I'd have 4 lines of symmetry. And let's look at classwork 1. I've already drawn mine, but you can see where, and obviously it's not perfect. I can go from vertex to base, vertex to base, vertex to base, vertex to base. And so I can see here that I've actually got 5 lines of symmetry because I have 5 vertices.
It drives me crazy that there's that line straightener.
Oh, and I forgot this one. I forgot to mark this one. Okay, so go ahead and draw yours if you haven't already. And you can see where I have those, I have 5 lines of symmetry there. Okay. But it's where it goes from vertex to base. So when I have 1, 2, 3, 4, 5 vertices, I have 5 lines of symmetry. Now it says, let's look at, for each of the digits 1 through 9, draw the lines that divide the numbers into congruent halves, if any. Okay, so like if I start with the number 1, now, if I have a 1 like this, I could cut it in half, couldn't I? Or I'll do a dotted line. I could have that, would be a line of symmetry. But when I have a 2, I can't cut it that way, nor can I cut it that way. So that one doesn't work. With my 3, as long as I'm perfectly proportional on the top and the bottom, then I could have it cut through that middle. Obviously, the printed 3s are going to do much better than our handwritten 3s. With a 4, again, I can't cut it like that. That doesn't work. That doesn't work. So that one doesn't work. 5, that doesn't work, nor does that. 6, nope, doesn't work. 7, nope. Now 8, again, if you draw perfectly with the same shape, same exact sizes, then you can cut it through the middle and cut it top to bottom. So that one would be, but not 9. Okay, so just kind of starting to recognize symmetry, recognizing that is all that we've got on this. So now what we're going to do is we're going to shift and go back to our worksheets. Okay, so if you have your worksheet packet, go ahead and pull that out. So far, we have worked on the first page where we did our area formulas, area and perimeter. Then the next page, we had a little bit dealing with the perimeter and area of our polygons or of our quadrilaterals. We did perimeter and area of triangles and trapezoids. The other day, we looked at our different angle, side angle, and side angle sides. And so now, this page says, draw a line of symmetry in the figure below. Well, I hate it when they repeat the same thing. It's exactly like it was in our workbook.
It says draw a line of symmetry, not more than one. So it just wants you to draw one, or what?
I guess so, yeah. Just draw one and you can pick whichever one. So just draw a line of symmetry, pick one and draw it. All right. And then activities 2 says list the 4 congruence patterns for congruent triangles. For each congruence pattern, draw and label a pair of congruent triangles. So let's think about those congruence patterns that we had. Remember, there were 4. The first one was side, side, side. The second one we looked at was side, angle, side. The third one was angle, side, angle. And the fourth one was angle, angle, side. Okay. So now for each one, we need to draw congruence patterns. So let's start with number one. We're going to do side, side, side. So in this one, basically, I'm just going to draw two triangles that are going to look the same, but I'm going to mark, when I mark them, remember this is where I use my hash marks. When I'm showing side congruence, I'm going to use my hash marks. So if I start with my first one, then I'm going to have one hash mark that matches up with the side of the other triangle. So for my second side, I'm going to use two hash marks. Second side, 2. And for the third one, 1, 2, 3. 1, 2, 3. Okay, so that shows me side, side, side. I'm able to look at one triangle and see which side is congruent in the second one. Look at my first triangle again and see what the second side is congruent to the second one. Go back to my first triangle and see what third side is congruent to my third side of my other triangle. All right, now we're going to have side, angle, side. So let's take a look. And if I were to have, let's see, I'm going to do right triangles here. So I can show that I've got this side is congruent to this side using my single mark. Now I'm going to use my 90-degree or use my angle here. And I'm going to put my little angle congruence where it's just the single arc. But now I'm going to show two marks for the bottom. And that shows me I have a side, then an angle, then a side, and they're all continuous. They're all consecutive. They're right in order. I don't jump a side to get to something else, or I don't jump an angle. I have to go right in order. All right, our third one we're going to look at is angle, side, angle. So let's see, I'm going to go like this. That's not good. And again, they don't have to be exactly perfect. But now I'm doing angle, side, angle. So I'm going to start with this angle up here and say, okay, if this angle is congruent to this angle, now I'm going to do the side in the middle, side. So if I'm doing angle, side, angle, then my next angle would have to be this one because they have to be right after each other. So angle, side, angle. I have the same angles, the same sides, the same second angles showing congruence. So that's angle, side, angle. And then my last one is going to be angle, angle, side. Angle, angle, side. So let's see. I don't want my triangle to be. Let's go like that. And again, it doesn't matter what shape you draw them in. All right, so for this one, I'm going to start with this angle here is congruent to this angle here. Okay, so I've got those. Now I've got to go to the next angle in order. So I'm going to go to the angle below it. So now I have an angle and an angle, but now I've got to mark the side that is continuous right off of that angle. So I'm showing angle, angle, side, going counterclockwise, or going clockwise, sorry. Going clockwise, I started with an angle, then I went to my next angle, and then I've got a side. So that's angle, angle, side. Okay. So that's dealing with my types of congruence. And again, that's going to be something that you will see. I want to say maybe we touch on it a tad in Algebra 1, but you really see it a lot in geometry. Okay, so this will be something you'll see again, but it won't be till later. Just remember that seeing those marks indicates congruence. A single hash is congruent to a single hash, and that means they are exactly the same size. A single arc for an angle compared to a single arc and an angle. If they are marked the same, then I know that I can trust that they are congruent, which means they are the same angle measures. Okay. Oh. All right, and that is the end of our packet there. So you should have a completed packet by now. And so what we're going to do is we are going to review. We're going to look through everything that we've talked about, and we are going to review for our test. I know y'all are so excited about that. Let's see. Yeah. Okay. So let's talk about the things that we definitely need to remember how to do. Let's go ahead and flip back to lesson 81. Go ahead and turn in your book to page 179, lesson 81. Okay, in lesson 81, we started talking about our plane geometry terms. Okay, so we learned about points and lines and line segments and planes and rays and parallel lines, all that good stuff. Okay, so you need to, just like how we have the chart on the next page where we had to tell what the name of a point was and what the symbol was, how to name a line, how to do the drawings and the figures. You're going to need to do all of this. Okay, so we'll be working with completing a chart with points and lines and segments, rays, angles, and parallel lines. Okay, and then we'll move on to the next thing. And we talked about parallelograms and rhombuses. And so let's see, you will have a parallelogram, but not a rhombus on there. And so you'll need to be able to tell how to find the perimeter and the area. So remember, the perimeter for a rhombus and for a parallelogram, we just add all of our sides together. Okay, so perimeter is side plus side plus side plus side. But then for my area of a parallelogram, remember, area equals base times height. And remember, our base is going to be this one. Now, it could be this one. It depends on which one is marked, but usually it's going to be the bottom one. So remember, this is my base, and this is my height, where I have my diagonal that shows me my height. And so to find base times height, I just multiply the two together. Okay, so perimeter, you just add your sides, area, base times height. Any questions about that? All righty, and then after that, we looked at rectangles and squares. And we have the same formula for a rectangle, where for perimeter, you can either use 2 times the length plus 2 times the width, or you can just do side plus side plus side plus side. Okay, for perimeter, the main thing is if you just always remember you add your sides together, you're going to be just fine no matter what shape it is. Okay, perimeter, you're just always adding your sides up. But then for the area, we know that the area is going to be base times height. And so my base is always going to be my long side and my height will be my short side. Or if it's flipped around, it really doesn't matter because multiplication is commutative. So it doesn't matter if I multiply 7 times 4 or 4 times 7. Okay. And then we had our trapezoid. And actually, let's see, we will have a trapezoid. We do not have a triangle on here, do we? You will not have to, you will not have the area of a triangle. But remember, area of a triangle is 1/2 base times height. But we do have the area of a trapezoid. Okay, and so remember with my trapezoid, it's going to be area equals 1/2 of base 1 plus base 2. I have to add my bases together and then multiply by the height.
Is the trapezoid going to have like the square root side?
You know what? It does, but I'm going to change it. Okay, I'm going to make it be whole numbers. So
That's really, really, really annoying.
I know I don't like that either, but I will alter that. Okay, what I will do is actually I'm going to make looking at it, they all of them either have fractions or decimals or square roots, and I'm just going to make them regular numbers. So I'm just going to make it, because the main thing right now is it's, you know, you'll work on more complicated ones later on in math. I just want you to be able to understand how to plug the numbers into the formula and be able to solve. So
it's like they're purposely trying to torture whoever's taking it.
Horizons for some reason loves using those square roots. So, but don't stress about that. I will fix that. Okay. And then we do have some on circles. So circles, remember, a radius is half of the diameter, and the diameter is 2 times the radius. So just remember your relationship between radius and diameter. Circumference is going to be either pi times d or 2 pi r. And what I'm probably going to do, and then area is pi r squared. I'm probably just going to go ahead and I'll probably put your formulas on there for you, because right now I'm not as concerned about you memorizing the formulas as I am you just learning how to use them and plug them in. And so also the other thing that I am going to do for my circles is I am going to have you go ahead and would y'all rather leave your symbol as pi, or do y'all want to multiply by 3.14? Or I'll give you the option. How
I
about
like
that?
multiplying by 3.14.
Okay, I'll give you the option on it. Okay, so on the directions, I'll alter it to where, you know, you can either leave your answer as pi or you can multiply it by 3.14. It's up to you. Okay. And then the last thing will be, let's see. The last thing we'll have congruent triangles. Let me go here. Okay, so basically it'll say, like, using the marks, what angles can you tell are congruent? So like on here, I can see that angle A is congruent to angle D. I can see that angle B is congruent to angle E. And I can see that side AB is congruent to DE. Okay, so it'll ask you using the marks to tell what you can tell are congruent. Okay, and so here I've got angles, and I've got a side. My side is in between the angles, so that's angle, side, angle. Okay, so and I think that will be it on that. Okay. So I tell you what, let's take a look. So realistically, what we'll do is Does anybody have any questions about this? I really, we're at a point where we're ready to do the test. I don't want to start anything right before the break. Since we're going to take a week off, I'd rather just wait. So, we're really done for the day. So I know y'all be brokenhearted if we got out of class this early, if we got out of class at the break. Would that hurt anybody's feelings if we ended early today? No, Lyria's like,
No.
everybody's like, no, everybody will turn their screen on for that, won't you? Y'all turn your screens on to say, we're good, we're out, peace. Okay, so what I'll do is I'm going to get ready and alter the test real quick. I will get the measurement things changed that I was telling you guys about. I'll fix those numbers, and I will get ready to email you your test. And so your test will be due on the Monday that we return after the break. Okay, so the only homework that you have will be to do your test. If you come to co-op on the Monday after break, bring it. If not, you can submit it online. And that's all we've got. So you'll bring your packet. So after the break, your packet will be due and your test will be due. And then that'll be it. Any questions? I mean, if anybody wants to hang around with me, I'll stay on Zoom and we can sit here and talk. But if you are ready to go, then go and have a great break. Okay? Enjoy your time off, and I will see y'all after next week.
Goodbye.
All right. Bye, guys.
Have a good break.
Thanks. You too.